That's some Boolean logic by Eric, Drake, and Ashley. Contents page. Who was George Boole? George Boole was a British mathematician, philosopher, and logician who is best known for his work on the mathematical foundations of logic. He is considered one of the founders of modern symbolic logic and the inventor of Boolean algebra. He is what we know as today as the person who made true or false for pretty much the binary computer. Boolean algebra in our own words. Eric says it's the logic used in some of the intelligence application I use to search for information. I say Boole logic to me means whether a function in the system is going to work or not. Either works with it, works alone, or doesn't work at all. And Ashley says Boolean algebra to me is a way to manipulate digital logic with values that represent true or false. What is Boolean logic? Logic values are represented using binary digits, with 1 representing true and 0 representing false. Logical operations such as and, or, and not are then used to combine these values to form more complex expressions. For example, the logical expression A and B is true only if both A and B are true. The expression A or B is true if either A or B or both are true. The expression not A is true if A is false, and false if A is true. It's pretty much saying, like, if you have an A and a B, then it's true. If you have just an A or just a B, or both of them, then it's also true. But if you have an A and it's true, then it's not going to work. What's so significant about Boolean logic? Because it is a fundamental concept that is used in many areas of science, engineering, and technology, here are some reasons why Boolean logic is so important. It provides a way to reason about and manipulate logical statements. Boolean logic provides a way to reason about logical statements using a set of simple rules and operations. This makes it possible to manipulate and analyze complex logical expressions, which is essential in many fields. It forms the basis of digital circuit design. Digital circuits are built using Boolean logic gates, which implement Boolean function. That means that Boolean logic is the foundation of digital electronics and computer science. It is essential for computing programming. Boolean logic is used extensively in computer programming to control the flow of execution and to make decisions based on different conditions. What are some applications of Boolean logic? Data analysis. Boolean logic is used in data analysis to filter, categorize, and analyze data based on different conditions. Telecommunications. Boolean logic is used in telecommunication networks to control the flow of data and to make decisions based on different conditions. Robotics. Boolean logic is used in robotics to control the behavior of robots and to make decisions based on sensor data. Digital signal processing. Boolean logic is used in digital signal processing to manipulate digital signals and to filter out unwanted noise. Control systems. Boolean logic is used in control systems to control the behavior of complex systems such as aircraft and spacecraft. Artificial intelligence. Boolean logic is used in artificial intelligence to represent knowledge and to make decisions based on logical reasoning. Overall, Boolean logic is a powerful tool that is used in many areas of science, engineering, and technology. Its simplicity and versatility makes it a fundamental concept that is used to solve complex problems and design complex systems. Now, some backstory on George Boolean. It's 1847, and George Boolean has started developing his algebraic system. At this point, nobody has done it in 150 years or has attempted to it. The only previous attempt of logic-based math was from Gottfried Lisbon, and as I said, it's been 150 years before Boole. This is 2 years before George Boole started working at a university. Now from 1849 to 1859, George Boole has started working as a professor at Queen's University in Cork, Ireland, where he has lived the whole time. 1857, became part of the Fellowship of the Royal Society. 1858, honorary member of the Cambridge Philosophical Society. In 1859, he got his degree of DCL, honoris causa from Oxford. The DCL is the Doctor of Civil Law, which allows contribution to legal research and knowledge. And without that, his research for the Boolean algebraic system would probably not be well known. Now, in 1860 to 1864, he had one of his daughters, Alicia Boole, who will coin the word polyotope. Not sure what a polyotope is, but that's what she did. Also in 1860, published Differences Equations used as a textbook at Cambridge. George Boole also had two more daughters during this time period. One of his daughters published a book called The Gadfly, which was very popular in Russia. He eventually died giving a lecture in the rain and he caught pneumonia, a very common disease during this time period. And at the start of his career, George Boole developed a logical math that was used in computers today. He took a system called Aristotelian logic and applied it mathematically. Taking what Aristotle created, he broke it down into a modern-looking equation. V for virtue, P for passion, F for falsities, H for habits, D for things accompanied by deliberate preference, G things causing their work to be in a good state, M things keeping the mean in view relative to human nature. Using the symbols he defined, Boole restated Aristotle's premise in algebraic terms. An even further breakdown of what he did. I'm not going to read that whole thing. This is the first instance where Boole ignored what Aristotle meant and used his mathematical logic, where V, virtue, equals H times 1 minus F times 1 minus P. And using his personal interpretation, the equation ended up as virtue equals HDM. George Boole releases his book in 1847, Mathematical Analysis of Logic. This is the book used for modern logic algebra. Boole's equation was built around this function P1 equals Q1, Pk equals Qk, so P equals Q. You can break this down in modern math by replacing these with X, Y, and Z. Here's a chart to make it easier to read. Boole changed everything. George Boole, the famous mathematician and logical thinker, publishing multiple papers for math and law. By taking what he learned from law and math, he was able to invent a system of logic and whether an input of numbers would be true or false. By making those numbers true or false, would determine if the outcome would work. George Boole did not know the impact he would cause for the future, but without him we would not have our modern day world. Laws of Boolean algebra. These laws simplify expressions in Boolean algebra: associative law, annulment law, complement law, commutative law, distributive law, and identity law. These are the definitions of associative and null laws. Associative laws deals with the grouping of operations. This law states that the way the variables are grouped together does not change the results, or and in their examples. Annulment law is also known as zero product property, states that the value of a variable will always result in a zero if it is added or multiplied by zero. Or example, 0 plus b equals 0, and example, a times 0 equals 0. Both operations, example, a times b plus 0 times c equals 0. Commutative laws deals with the order of operations, allows for reordering terms without changing the given values. This law states that the order of the variables does not change the results when using or and operations. Or is an addition, example, a plus b equals b plus a. A multiplication example is a times b equals b times a. It's pretty much stating that you can move your terms as long as you don't change the symbols. Complement law states that every variable has a complement which is the opposite of that variable. Produces a value of 1 when combined with its original value. It is denoted as a or not a, also known as a bar. Here are two examples. Since a is true, which is represented as 1, then not a is false, represented as 0, so the expression is also false. Distributive law allows to distribute variables across parentheses, states that a variable can distribute across parentheses by multiplying or adding it with the terms inside parentheses. And here are two examples. Identity law states an operand can be combined with an identity element without changing the value of the expression. Identity law for OR identity element is 0, and any OR expression with 0 remains unchanged for variable a. Example, a plus 0 equals a. Identity law for AND identity element is 1. The AND expression with 1 remains the same for variable a. A times 1 equals a. And here is a list of all the operations and laws that we just looked over. Feel free to pause. In our works cited page, and that is the end. Thank you for listening.